To everyone that's joining me for this video, thank you for watching this video and my other videos. I am Mr. Ish. We're looking here at a part 3 video here on circle problems. Why? Because circles are too common on any kind of exam. Our question number 1 is to find the area of this shaded region. Given that we have the radius is equal to 1 for each of those circles, each of the circles has an area which is equal to each other. You can see this area which comes in between the shaded area. We have to do that. How do you go about doing that? If you were to connect these dots which represent the centers of these 4 circles, you have generated a square. You know the radius in all dimensions is a 1. You got a 1 going across in every way. If you were to calculate the area of the square, it would be much larger, right? Think about it, it's much larger. If you were to do the area of the square and minus from that the area of these sectors which actually form. Think about it. You have a little bit of a sector which forms right over here. Right over here. I've taken this piece out and I've plucked it out, and it's a sector, an area of a sector. And you were to do 4 of these areas of these sectors, you'll get the area of the shaded region, and that's exactly what we have to do. You know the area of the square is easy. Each side has a length 2. You're going to do 2 times 2, you'll have a 4. Now we have to find the area of one sector. Each sector has an area which is equal to half r squared theta. If you didn't want to do this way, the sector way, think about all of these 4 individual sectors give you the area of one circle. Just find the area of one circle. That's equal to the area of 4 sectors. Each of these sectors has a radius of 1 and an angle over here. You know this angle is 90 degrees because we have a square involved, which is pi over 2. You'll have half times 1 squared times pi over 2. And what does that give you? That gives you a pi over 4. That represents the area of one sector, and you have 4 of these, and you get the area pi. That's my pi coming from 4 sectors. Let's look at it in second way. If you wanted to ignore the whole sector idea, I told you 4 sectors gives you one of these circles, because each of these 90 degrees, 4 times 90 gives you 360 degrees, a full circle. You could have just done area of one single circle which accounts for 4 sectors, and that would be pi times 1 square, and that again would be pi, and you get that. So what's the area of the shaded region? It's going to be 4 minus pi, and that right there will be your answer. Our second question for this is an interesting one. A circle has a circumference 2 pi. What is the arc or the arc length that is represented by a single degree? We have 2 different types of conventions being talked about. Here we're looking at something in form of radians, and here we're talking about degrees. We know 360 degrees is equal to 2 pi in terms of radians. Think about it. Pi is 180, 2 times 180 is 360. If a circle has a circumference of 2 pi, what is just subtended or represented by a single degree? If you were to look at this just right here, 1 degree, what would be the arc length over here? How can you represent 1 degree in terms of a radian? We always want to talk about arc lengths and arcs in terms of radians. R-A-D, rads. If you have 1 degree, you multiply that by pi over 180, because that's the formula to convert between degree and a radian, and 1 degree is equal to pi over 180 rads. Let's look at the circumference. 2 pi r, which is the formula for circumference of a circle, is equal to 2 pi. Take the 2 pi on the other side, radius is equal to 1, right? I know now the radius is equal to 1. We know that what is the arc length represented? Arc has a formula, arc length, S is equal to r theta. You now know the radius is equal to 1, and you know the degrees in terms of radians, the angle is pi over 180. So what's the arc length represented by 1 degree? It's 1 times pi over 180, and it's pi over 180, and that right there is your answer. And keep exactly what I've talked in mind over here with regards to this question. Memorizing this formula is not a bad idea. This is arc length. The arc length, which is a length measured and subtended by an angle, exactly that, is equal to the radius times the angle in radians which it is involved with. Keep that in mind. Thank you for watching this video. Have a good day.